Hi guys, let's start with the new topic, multiplication of matrices. Now till now we've learned how to add and how to subtract, and we've also learned how to multiply a matrix with a scalar quantity, which means a number. Now let's see how we can multiply matrix 1 with matrix 2. There is one specific thing, which is it is possible only if R1 C1, which is row 1 and column 1, and row 2 and column 2, it is possible only if column 1 is equal to row 2, which means the number of columns in the first matrix is equal to number of rows in the second matrix. And the order of the final product, which is when you multiply these two matrices, would be R1 and C2, which means 2 and 3 need to be equal, and the answer will be 1 and 4. Let's see this question, let's see a couple of questions and it will become slightly more clear. So let's look at it. How do we multiply? So the multiplication is, let me change color. You go row first and then you do column. Then you go row again and then you go column. So you go row multiplied with column, row multiplied with column. So right now what we are doing is a 1 by 2 matrix, 1 row 2 columns with 2 rows and 2 columns. Let's first check compatibility. Number 2 and number 3, which is 1 into 2 matrix multiplied with 2 into 2 matrix. These two numbers are equal, which means they can be multiplied, and my order of the final matrix will be a 1 by 2 matrix. So let's look at it. So first term will be multiplied with the first term. Like I said, go horizontal and go vertical. So first term will be multiplied by this number plus the second term in the row multiplied with second term in the column. Done. Next, 1 multiplied with 3 plus minus 2 multiplied with 4. So this will be negative 2 plus 2, and this term will be 3 minus 8. So this will be 0 and negative 5. The order of this matrix is 1 into 2. So basically we go here and here. Again, we keep doing it the same way again and again. So right now I did a 1 by 2 into 2 by 2. Now I am doing a 2 by 2 into 2 by 1. Let's check if they are compatible. Number 2 and number 3 elements are equal, which means the order of my final matrix will be 2 by 1. So they are compatible. They will be, I can multiply. So here I go this and then I multiply this with here. Next I would go here and I will multiply it again with this. So let's look at the answer. So the final answer will be 2 into 1. That will be the order of the product. So let's look at it. So it will be 6 into negative 1 plus 4 into 3. That will be my first element here, and the second element would be 3 into negative 1 plus negative 1 into 3. So this is negative 6 plus 12, and this is negative 3 minus 3. So this is equal to 6 and negative 6. Done. Right? So this will be 6 and negative 6. Let's look at the next question. The next question that we do is question number 1 part 4. So question number 1 part 4 is again a 2 by 2 matrix with a 1 by 2 matrix. So let's look at this. So let's check if they are compatible. 2 and 1 are not equal, which means they are not compatible. Since column 2 is not equal to not column 2, since column 1 is not equal to row 2. This is my matrix 1 and this is my matrix 2. So since column 1 is not equal to row 2, these two matrices can't be multiplied. Perfect. Now let's look at question number 2. Question number 2 says if A is equal to 0, 5, 2, negative 2 and B is equal to 1, 3, negative 1, 2 and I is a unit matrix of order 2 by 2. So remember what is a unit or an identity matrix? Unit or an identity matrix is a matrix which has the primary diagonal as 1 and all other elements as 0. And this is always a square matrix. So this is a 2 by 2 matrix which is 1, 0 and 1, 0. Perfect. So let's look at the question. It says find AB. So whenever you're doing AB, you start multiplying from the first number is A and then you write B. So first matrix is A, then you write B. So now we are doing a 2 by 2 multiplication. So this is 2 into 2 and this is also 2 into 2. So since 2 and 2 are equal, which means my product will also have a order of 2 by 2. So let's look at this. Let me first draw my how would I multiply. First I'll multiply it with here and then I'll multiply it this way. So let's look at this. So the first term will be 0 into 1 plus 2 into 3. Done. Next, the way we were doing earlier, I will look at 0 into 2, 0 and this one. So let's look at this. It will be 0 into negative 1 plus 2 into 2. Next, I take the second row and I am first multiply it with this column and then later I'll multiply it with this column. So let's look at this. It will be 5 into 1 plus negative 2 into 3 and the fourth element will be 5 into negative 1 plus negative 2 into 2. So this is 0 into 1 is 0, 2 into 3 is 6. Next, 0 into negative 1 0 plus 2 into 2 that's 4. 5 into 1 5 and this is negative 6, so that's 5 minus 6, that's negative 1 and that's negative 5 and negative 4, so that's negative 9. We'll do adequate number of questions so that becomes clearer. Let's check BA. Same question, but now I am multiplying B with A. So let's see how would it work. So let's do, I'll take this, then I'll multiply it with this, then I'll take 1 negative 1, multiply it with here, then I'll take 3 2, multiply first here and then here. Let's look at the answer. So it'll be 1 into 0 plus negative 1 into 5, 1 into 2 plus negative 1 into negative 2. Done. Let's look at the next one. 1 into 2 plus negative 1. This is 3 into 0 plus 2 into 5 and there will be 3 into 2 plus 2 into negative 2. So this is 1 into 0 is 0 and this is negative 5. This is 2 and plus 2 that's 4. This will be 3 into 0 0, 2 into 5 is 10, 3 into 2 6 and this is minus 4. So 6 minus 4 gives me 2. Now let's check if AB and BA are equal. Well, the first element itself is not equal. So what I can realize is AB is not, may or may not be equal to BA for matrices. Right? So I hope you remember this property of 2 into 3 is equal to 3 into 2 when we talk about numbers and algebra. But in matrices, A into B may or may not be equal to BA. So it is not equal to BA. It will depend on the specific question. It may or may not be, but it is not given equal to BA. Let's look at question number 2, part 3. We need to find AI. Now, since we need to have what should I say? Identity matrix is always a square matrix with the primary diagonal as 1 and all elements as 0, and we need to have a compatible matrices for multiplication. This is a 2 by 2 matrix, which means this will have to be a 2 by 2 matrix. So I would in this case be 1 0 1 0. So let's multiply. Let me look at how I do it. 0 2 will first get multiplied with 1 0, then it will get multiplied with 0 1, and then I will have 5 and negative 2 will get multiplied with 1 0 and then get multiplied with 0 1. So let's look at this. This will be 0 into 1 plus 2 into 0 and then 0 into 0 plus 2 into 1, 5 into 1 minus 2 into 0 and 5 into 0 plus negative 2 into 1. So this will be 0 into 1 is 0 and 2 into 0 is 0. So this is 0, 0 into 0 is 0, 2 into 1 is 2, 5 into 1 is 5. So and this is 0, so this is 5, 5 into 0 is 0 and negative 2 into 1 is negative. Right. So A into I, this is AI. Does this look like A? Yes, so A into I is A. Remember, we've talked about a multiplicative identity in when we're doing numbers in grade 6 or grade 7. Multiplicative identity is a number which when multiplied to a given number gives the same number, which means 3 into something should give me 3. So this something is 1 for numbers and this is known as the multiplicative identity. Here in this case of matrices, all unit / identity matrices are multiplicative identity, which means A into I will always give you A in case of a matrix. The only condition being that the two matrices, which is A and I, should be of the same order. Now let's look at part 5. We're looking at part 5, which is A square. So A square, what does it mean? So A square doesn't mean you square all the numbers. This is completely incorrect. It means A into A. So let's do this. Again, we will have to follow the pattern. This will first get multiplied here, then will get multiplied here, and then the second row will get multiplied with first column and then with the second column. So let's start writing our answer. So this will be 0 into 0 plus 2 into 5, then 0 into 2 plus 2 into negative 2, 5 into 0 plus negative 2 into 5, and then the last element will be 5 into 2 plus negative 2 into negative 2, and that's my matrix. So 0 into 0 0, 2 into 5 is 10, this is 0 into 2 is 0, and 2 into negative 2 is negative 4. Here this is 0, negative 2 into 5 is negative 10, and that's 10 plus 4, which means 14. So that's A square. Good, we've done some decent work. Let's move on and let's open the next question that we need to do. The next question that we do is question number 2, part 6. So when it comes to B square A, what does it mean? It means that I will have to start multiplying B into A, and when you multiplying, we go from left to right, which means first I will multiply B with B, and then whatever answer I get, I'll multiply it with A. So note in numbers multiplication or in algebra, if it's x square y, if I had x square y, I could multiply x with y and then multiply with x, or whichever way I wanted. But in case of matrices, I will first multiply B with B and then multiply it with A. So let's look at what would B square be. Right? So let's B square would be to save space. I don't have enough space here, so I will do B into B and then I will do B into B square into A. So B into B would be 1 negative 1 3 2. Is that B? Let me just reconfirm from the question. Yes, 1 negative 1 3 2. Multiply this with 1 negative 1 3 2. So here I go like this, and then I go here, and then I same with row column 2. Similarly, row 2 first with column 1 and then with column 2. Let's multiply. So this will be 1 into 1 plus negative 1 into 3. This is, I'm calculating B square now. and the second will be 1 into -1 plus -1 into 2. So first I multiplied with column 1, then I multiplied with column 2. Next is 3 into 1 plus 2 into 3, and then is 3 into -1 plus 2 into 2. So this will be 1 and plus 1 into -3, that's -3. So this is equal to -2. 1 into -1, that's -1, and that's -2. So this is -3. 3 into 1, 3 plus 6, that's 9. -3 plus 4, that gives me 1. So now let's do b square a. B square a will be -2, -3, 9, 1 multiplied with a, and a is 0, 2, 5, -2. Yes, 0 to 5, -2. Let me again put arrow for our understanding. Row 1 with column 1 followed by column 2. Then row 2 with column 1 followed by column 2. So let's multiply. This will be -2 into 0 plus -3 into, is this plus 5, -5? This is plus 5 into 5. And then the second one will be -2 into 2 plus -3 into -2. Done. Next column, next row rather, 9 into 0 plus 1 into 5, and 9 into 2 plus 1 into -2. So -2 into 0 is 0, and this is -15. So this is the first element here is -15. -2 into 2 is -4, and this is plus 6. So -4 plus 6 gives me plus 2. This is 0, and this is 5, and this is 18 minus 2, which gives me 16. Perfect. Let's move on and let's do question number 4, part 2. It says find x and y if. So we need to do some calculation and see if we can figure out what we're looking at. So here it says matrix 1 multiplied with matrix 2 gives me matrix 3. Again, let's check if they are compatible. This is 2 into 2. This is also 2 into 2. So this is compatible. So which means my final answer, the value, the product will have the order of 2 into 2, which is given. So let's multiply and see how it works. Again, row 1 will first get multiplied with column 1, then with column 2. Then row 2 will get multiplied with column 1 and then with column 2. So let's multiply. So it is x. So I think it will give me some form of simultaneous equation or a simple equation. So x into 1 plus 0 into 0, and this is x into 1 plus 0 into y. This is -3 into 1 plus 1 into y, and this is -3 into 1 plus 1 into y, and this is my left hand side, which is equal to 2, -3, 2, -2. That's my right hand side. Let's move on. So how would the multiplication work? This is x into 1 gives me x, plus 0 is 0. This is again x. This is -3 plus, this will be 1 into 0. That's a mistake that I have done. My mistake. So this will be -3 multiplied by 1 plus 1 multiplied by 0. This will not be y. This will be 0. My mistake. So row 2 multiplied with column 1, and then row 2 multiplied with column 2. So this will be 0. So this is -3 plus 0. So this is -3, and this will be -3 plus y. This is equal to 2 to -3, -2. So each component is equal to the corresponding component, which means x is equal to 2, and x again is equal to 2, and -3 is equal to -3, and -3 plus y is equal to -2. So you will write on comparing corresponding terms, we get x is equal to 2 and -3 plus y is equal to -2, which means y is equal to -3 plus 2, which is negative 1. Negative 3 plus y, no, negative 3, no, this is again a mistake that I am doing. This is y is equal to negative 2 plus 3. I'll take negative 3 on the other side. So it will be y is equal to negative 2 plus 3, which is equal to 1. So I will highlight my answer. X is equal to 2 and y is equal to 1. I can also write my answer in a set form. It will be 2 comma 1. Do they ask the answer in a specific form? No, they just say find x and y. So I've already found x and y. That should be enough for this question. Let's look at question number 6. Question number 6 is given A is equal to something and B is equal to something, is the following possible? So this is a 2 by 3 matrix, 2 rows and 3 columns. Perfect. And this is a 3 by 2 matrix, 3 rows and 2 columns. So is A into B possible? So it's a 2 by 3 matrix multiplied with a 3 by 2 matrix. Since these two elements are equal, yes, it is possible. Perfect. Do they want us to multiply? No, they don't want us to multiply. Next, is BA possible? Let's look at BA. BA is 3 by 2 multiplied with 2 by 3. Since these two elements are equal, this is yes, it is possible. And what will be the order of the resultant matrix? Order of product here would be 2 by 2. Here, order of product will be 3 by 3. Perfect. And let's look at A square. So A is a 2 by 3 matrix, 2 by 3 matrix, which needs to be multiplied with a 2 by 3 matrix. Now, is 3 and 2 equal? No. Since C1 is not equal to R2, therefore A square is not possible. You will write this as full line, which is column 1 not equal to row